Hello, a very good evening to everyone. My name is Oritro and I will be your host for today's session. Our today's session is Moon Mania in Monsoon. This 13th of July, on the occasion of International Moon Day, we at Hex-Star Universe, in collaboration with Moon Village Association, have brought you an amazing free live session on YouTube. Our speaker for today is Dr. Patrick Das Gupta, Professor, Department of Physics and Astrophysics, University of Delhi, PhD in Cosmology from TIFR, Mumbai Research Association in IUCAA, Pune, India. So now I would request Sir to please carry on with this session.
Thank you, Aritro. I must start
Yes,
by
sir.
thanking Shommojit, who first got in touch with me and invited me to give talks. I thank all the team members of Hex-Star Universe. All right, I'll start my talk. So let me go to the screen. I hope everyone can see the first slide of my talk.
Yes, sir,
Right.
it is visible.
First of all, I dedicate this lecture to my late wife, Dr. N. Ratnashri, who left us to the heavenly abode because of COVID last year on 9th of May. Uh, Particularly because today is also the supermoon day, and I remember Ratnashri as the director of Nehru Planetarium, New Delhi. She used to always arrange a public viewing of any of the events related to celestial objects, in particular things like supermoon, eclipses, occultation by moon, and also sometimes the songs which have moon and moonlight explicitly. And she used to have gathering of people and invite people to sing songs that has moon and stars in the lyrics. As I said, today is also uh, the supermoon day. I don't know about Delhi, but where I'm at the moment in Hyderabad, where the sky is overcast and it has been raining incessantly. And obviously, I can't have a glimpse of the supermoon. And also, yesterday was one of the epoch-making day when James Webb Space Telescope researchers, they made public the some of the pictures which have been taken using this space telescope, and you can see here galaxies that are interacting, and because of the tidal gravitational effects, you can see plumes of gas. And because this telescope operates at the infrared regime, you can see the infrared emission from the you can see the light emitted from the gas, but because these are far away, they have got redshifted to the infrared regime. Right. Now let's come back to the main theme of the talk. Of course, moon has fascinated our ancestors since the days of river valley civilization, and it is therefore not surprising that there is already quite a bit of hymns and mythological tales associated with moon. For example, in Mahabharata, moon is associated with the story of Amrita coming out of the Samudra Manthan. As you know, the Samudra Manthan, where the Basuki snake around the Mainak Parvat on Kurma Avatar, when the ocean was churned, many fascinating things came out of the ocean, including the ambrosia, or the nectar that made gods immortal, which we call Amrit. And uh, it was the duty of the moon god and the sun god to see that the Amrit, which were kept in pots, were not stolen by the Asuras. And there was one uh, Asura who, in a clandestine manner, tried to have the Amrit, and it was Rahu. And sun god and the moon god, they immediately warned the other gods that Rahu has partaken some amount of Amrit, and immediately, uh, according to the mythology, Lord Vishnu's Sudarshan Chakra, it beheaded Rahu, and the tail part is today known as Ketu, while the head part is Rahu. And because Rahu had already consumed some amount of Amrit, so therefore Rahu and Ketu kept were immortalized. And according to the Mahabharata tale, the lunar and solar eclipses were caused by the Rahu, which was the head part of this Asura. And the explanation is, since Rahu was very angry with Sun and Moon, who had sort of notified the Devas that he was uh, having the Amrita, so therefore Rahu uh, on occasions swallows Sun. That is how solar eclipse takes place, but the sun cannot stay only within the head, so it comes out, and again the sun is visible. And so is the tail when Rahu swallows Moon. So it was, of course, a mythological rendering of what happens during the solar and lunar eclipse, where the poet imagines some kind of anthropomorphic tale to explain the celestial events. Today, of course, we know, since the days of Aryabhatta in India, Aryabhatta clearly gave the right reason for lunar and solar eclipses, where moon plays one of the central roles. Of course, Chandra in Puranas is also called Soma. As some of you may know, Soma was very important to the Rigvedic Indo Aryans, uh, because the Soma juice, when it was consumed, they, the priestly clans, they would immediately be sort of stimulated, and they would have poetic visions, and they would keep awake the whole night and compose hymns. So Soma was given a lot of importance in Rigveda, and because the Soma drink in Rigvedic hymns was bright in color, uh, over the time Soma got uh, identified with moon god. We also know that in our Indian culture, we say, when we look at the full moon, we say that there is a rabbit sitting there. This tale actually originates from the Jataka tales concerning Buddha. As you know, in Mahayana Buddhism, there are these Jataka tales which talks about Buddha or Bodhisattva in different avatars. And in one of the Jataka tale, Buddha narrates that how in one of his incarnations he was born as a rabbit, or in Sanskrit Shasha, and because of his willing to sacrifice itself for the purpose of feeding the Indra god or Shakra god, Indra was so impressed with the rabbit that he broke down a mountain, drawing the ink out of the mountain and painted it on the moon. or that's the reason why moon is also called Shashanka. Now, moon is also associated in the uh, various Puranic tales as to why moon, it has several phases. On new moon day, there is no moon, but then slowly you see the crescent phase, and the moon becomes bigger and bigger, becomes finally the full moon. And then after that, there is the waning phase. The full moon starts decreasing in its shape and size, and eventually it goes to new moon. This waxing and waning of lunar phases was sort of explained in a mythological way in Puranas, where moon was supposed to have had 27 wives. As you know, there are 27 nakshatra, all the constellations over which moon passes by. These are all called nakshatra, and there are 27 of them. The nakshatras are like Rohini, Kritika, and so on. And it was the other nakshatras, they complained to their father Daksha that moon is sort of, he favors Rohini because moon spends more time with the Rohini nakshatra, and Daksha became very upset with that, and he cursed moon that he will just keep waning and disappear into nothing. And moon got very uh, frightened by this curse. He immediately ran to Lord Shiva and sort of requested Lord Shiva to completely nullify the curse. Lord Shiva said that, well, uh, a curse, once it has been uttered, cannot be nullified. But what I can do is, I can, after the waning phase, when you have reduced to nothing, I can make you again get the shape back slowly. But when you get your full moon shape, again the Daksh curse will operate. So you will undergo an oscillating phase where you wane, then you wax, and so on. Now, you might have already noticed one thing, that most of our Hindu festivals, they fall on full moon times. For example, Holi falls on a full moon day, and many other uh, festivals like Buddha Purnima or uh, the Guru Purnima celebrating Nanak's birthday, they are all associated with full moon. There is only one major festival, namely Deepavali, which falls on the Amavasya or new moon day. So the possible reason could be that on full moon nights, because the evening uh, are not so dark, it is lighted by the jyotsna of the full moon, and therefore festivities can go on even during the night time, because thanks to the rays from the full moon. So after all these festivities used to take place in the days when there was no electricity, and therefore one shouldn't be puzzled by the fact most of the Hindu festivals, they fall on full moon uh, times. Now, you also might have noticed that apart from comets, as you know, when comets, they come closer to the solar system, the comets develop tails, and the tails keep becoming longer and longer as it approaches the sun, because it's the sun's solar wind and the radiation pressure from the sun which sort of drives the loosely bound vapors like dry ice or water vapor, etc. And the pressure drives a tail which points outwards from the sun. And therefore, comets, as they approach the sun, the tail becomes longer and longer. Moon is the only other celestial object that that is whose apparent shape changes with time because of the lunar phases, and this can be seen through naked eyes. Of course, if one views other celestial object through telescopes, there is of course change of shapes in some of the objects as time proceeds. But comets and the moon are, to my mind, the only celestial objects that change their shape and they can be viewed through naked eyes. Uh, Similarly, moon, since it has fascinated our ancestors, so even science fiction authors cannot keep away from the fatal attraction of the moon. So, as far as I know, the first science fiction novel that was moon centric was H.G. Wells' The First Men in the Moon, where H.G. Wells, in that novel, imagined that a scientist has discovered a material that has anti-gravity, that is gets repelled by the gravity, and he uses this material which he names as selenite, because selena is the Greek goddess associated with moon, and the scientist names this anti-gravity material selenite, and he creates a spaceship to go to the moon. Of course, there are many other uh, fictions, science fictions based on uh, moon-centric events. Many of you would have read Tintin comics, where you have some of the Tintin comics like The Explorers of the Moon, The First Trip to Moon, and so on. Now, I will here ask you uh, two questions. You think about it. If you don't find the answers, then towards the end of the talk, if you ask me, I will give my answer. First of all, you would have seen that when the moon, it rises at the horizon, it appears much bigger than when it is at the zenith. And the same is true when it is setting. While setting, when it is near the horizon, it appears very big. Try to figure out why this happens. Let me tell you, I'll give you a hint. There is no physics in this. Similarly, the other question that might have bothered some of you is, if you take the crescent moon or uh, a gibbous moon, the dark part of the moon, which is not shining, you will find that the dark part is not as dark as the background night sky. That means the unlit portion of moon is somewhat marginally brighter than the background night sky. Try to figure out why this is so. There are, of course, other questions. For example, when I was 11 or 12 years old kid, I would find that on a full moon evening, I would become sort of more energized. I would be chatting with my friends with great gusto, and it was true about other friends too. So, a full moon seems to cast a spell on human beings. Try to figure out why. Right. Now, this part, I hope you can see this image of the moon, where the unlit portion of the moon is somewhat brighter than the background night sky. So, this is the background night sky, and the unlit portion of the moon is somewhat brighter because you can see the outline of the hemisphere, which is still dark. And of course, the bright portion is there, and the bright portion shines because the sun's direction is somewhere in this direction, and its light is falling on this part of the moon, and that's the reason why this part is brighter. This whole uh, effect of the unlit portion being brighter than the night sky and the crescent moon, this has been encapsulated in a beautiful manner by Khaled Hosseini in the novel And the Mountains Echoed. He writes, a delicate crescent moon cradled, so delicate crescent moon cradled the dim ghostly outline of its full self. So this is a beautiful way of talking about the unlit portion being cradled by the crescent moon. Of course, we all know that countless poets, composers, and singers have sort of been enamored by the moon and the moonlight, namely Jyotsna. Uh, Poets from Kalidasa, Banabhatta, Jayadev's Raslila, who talks about Krishna and the Gopikas dancing on a Jyotsna pervading night. Similarly, Shakespeare brings in moon and its waxing and waning phases in several of his plays relating to the uh, sort of changing nature of human beings, just like moon shapes change. And of course, the moonlight has been immortalized by the Beethoven's Moonlight Sonata. And we all know that there are countless romantic songs in every Indian language, sort of invoking moon and the moonlight. And this is natural because in the night sky, moon is the brightest object, and it sort of, as Kalidasa in some manner had said, it sort of frees the night of its loneliness when moon appears. Uh, right. So all this was so far not discussions related to science of the moon. Now I'll have to go to the science of the moon, because as the civilization progressed, suddenly science and technology started appearing on the scene, and we started understanding the nature not by the effects it has had on our poetic imagination, but the understanding were to do with objective truth associated with nature. Right. And the first man who actually made a scientific study of our moon is the great Galileo, the father of physics. He lived about 400 years ago, and the physics we study originated from systematic measurement, observations, and giving mathematical laws. So the same Galileo, he, by the way, he did not invent telescope, because telescope was invented, as many scholars point out, in the land of the Arabs, and but he made a telescope. So this is a telescope he made, and using this telescope, he studied many of the celestial objects. We know that he was the first to see the rings of the Saturn, first to find out moons around Jupiter, and so on. But in particular, he made systematic sketches of moon during its various phases, and he drew them himself. He found that there were craters that were scattered all across the moon, and by studying the moon during its various phases, he sort of, in a way, with whatever telescope resolution, limited resolution he had the first scientific and systematic study of the surface of the moon. Today, of course, with much powerful telescopes, we have a much better view of the surface of the moon, and you can see the moon is scattered with so many craters. Again, the question to you is, why are there so many craters on moon while on earth the number of craters are uh, far fewer compared to the number of craters on moon? So you can try answering it. But since I talked about the shasha or the rabbit on the moon, you can see here, you can imagine that this is the head of the rabbit, and these are the uh, rabbit's big ears, and this is the body of the rabbit, and this is the tail or portion of the hind leg of the rabbit. Right. As I said, moon is much brighter than, let's say, stars. Here is a glimpse of the night sky where you can see the constellation of Orion, and here is a Sirius. This is a Sirius A star. This is the hunter dog, and this is the hunter Orion. And this, as you know, the Betelgeuse, it is, astronomers believe that it's soon going to implode and give rise to a supernova explosion. But we don't know when. 100 years, 400 years, 1,000 years, and so on. There is a great deal of uncertainty. Right. And moon being the closest celestial neighbor, so that would be the first thing to reach. And indeed, the first rocket mission uh, to reach any celestial object whatsoever was the Apollo 11 moon mission, and it landed on July 20th, 1969. And to commemorate this day, July 20th is going to be celebrated at the as the International Moon Day every year. And you can see that Neil Armstrong, his famous saying, um, I don't know whether this picture he has already stated it or is in the process, but here the three, Buzz Aldrin and Neil Armstrong, they are setting up scientific experiments on the lunar surface. As you know, the one of the uh, instruments that was established on the surface of the moon was the lunar ranging, through which one could measure the distance of moon as a function of time. India, we in our first mission, Chandrayaan mission, India was successful. Indeed, the PSLV rocket, it managed to inject the Chandrayaan that went in an elliptical orbit around moon, and it led to several fascinating discoveries. The primary discovery that came out of Chandrayaan 1 mission was, it was established that the terrain of moon, a little below the top surface, there was water, because it had an instrument that sort of beamed radiation, and the radiation, after getting scattered from the water molecules, they were analyzed, and it was conclusively corroborated that the lunar soil does have water. You might wonder, why would there be water on moon? After all, the gravity being so low for the moon, uh, the escape velocity for the water molecules should be very low. They can just escape. The whole idea is that the radiation from the sun, particularly the ionic emission, the solar winds, they can cause chemical reactions, and that can create water molecules. So, yes, water molecules will be evaporating away and escaping. But since the solar wind is continuously falling on moon, so there is continuous formation of water molecules. And then the other uh, theory which has been put forward is that the some of the craters on the polar regions of the moon, since they never the bottom pit of the crater, they never see sunlight, any water, like the crater might be still getting bombarded by comets, and comets, they carry water, and the crater being in the dark side perpetually because of its depth, the water there would be in a frozen condition. Right. Now, uh, we all know why the phases in moon happen. Unlike the mythological stories, today we know, and this was known from the days of Aryabhatta in our country, of course, somewhat earlier. Hipparchus, he had understood eclipses and phases of the moon, etc. But in India, around 470 AD, Aryabhatta, in his great Siddhantic literature, the Aryabhatya, he had explained many things about lunar phases as well as eclipses. So the explanation is by now is obvious. Well, there is here, of course, don't bother about the size. They are not drawn to actual scale. They have been sort of, the moon and earth sizes have been exaggerated, and sun size has been sort of downsized. So don't bother about the sizes. But we know that, well, all radiations, all sort of brightened part of moons or planets, they are all due to reflected sun rays. So therefore, uh, when moon is somewhat between the earth and the sun, then obviously the bright part of the moon is away, and we don't see the bright part, and therefore that will be the new moon phase. And while when the moon is on the other side, then the entire this face is getting the full radiation, and therefore it would be full moon. Well, remember that this picture, it gives a false impression. It is not that the plane of moon's orbit around the earth is in the same plane as the earth sun plane, because had it been the case, then moon going to this position would be completely eclipsed by earth, and you will not see the full moon. I'll soon show you a figure which will make it clear. So just to clarify once again, earth is going around sun in an elliptical orbit, and let's say this is the plane that describes the earth going around sun. But the plane in which moon is going around earth, that is also an elliptical orbit, but the plane is somewhat inclined with respect to the ecliptic plane. Ecliptic plane is the plane in which earth is going around sun. We will show the picture that will make it very, very clear. And we know that there are times when you have lunar eclipse. Lunar eclipse takes place when earth exactly comes between the sun and the moon. It can happen, although there is the lunar uh, orbit around earth is inclined with respect to the earth's orbit around sun. But I will show you using the picture that there'll be time when moon, earth and sun, they are exactly in the same straight line. And then, of course, if the moon is at one end of the uh, straight line, then there'll be a lunar eclipse. While if moon comes in between sun and earth, there'll be it'll obstruct the rays from the sun to come in, and there'll be solar eclipse. By the way, this was completely understood by Aryabhatta. So he's the first Indian who gave the full theory of the eclipses. And here is the picture as to what is happening. So lunar eclipse, as you can see, uh, moon is exactly behind the earth. The centers of sun, earth, and moon are on a straight line, and therefore you can see that there is no light. Well, there is some light falling on the moon, because when the moon is exactly opposite, then the moon appears reddish. Why does it happen? Again, this I might have left it as a question, but let me explain this. Because of the Earth's atmosphere. So you have Earth's atmosphere, and the sun rays, when it goes through the Earth's atmosphere, the high frequency radiation like blue, green, etc., they get scattered more than the red. And the red gets less scattered, and therefore they get refracted and fall on moon, making moon look redder. This is exactly the similar to the reason as to why when moon or sun they are rising or setting, they appear redder. While solar eclipse happens when the moon comes in between earth and sun. Here you don't see a reddening or anything, because moon doesn't have an atmosphere. Okay. So we all know these two. I'm just, for the sake of completeness, I show the diagram of the lunar and solar eclipses, how they form. But let's explain why not every month you have a lunar and a solar eclipse. The reason is, as I said, that if this line, so imagine, of course, this is a 3D thing. So this line corresponds to the ecliptic plane. That means the plane constituted by the orbiting of Earth around Sun, while Moon is going around the Earth in a plane that is inclined to the ecliptic plane. Okay? And the angle between the Earth Sun plane, the blue line, and the Moon Earth plane, this is a red line, the angle between them is 5.14 degrees. Okay. While we also know another thing that we will talk about later, but since I am on this picture gives very relevant numbers. So Earth's spin axis is not perpendicular to the ecliptic plane. Rather, it makes an angle, and the tilt of the axis with respect to the normal to this plane is 23.44 degrees. Moon, of course, is also tilted. So nothing in real world is exactly in an ordered position. So obviously, we expect that things should be not in perfect order. But we will talk about this tilt and its significance soon. All right. And now I'll come to this fact as to why only on rare occasions you have solar eclipses and lunar eclipses. Here again, the diagram has been exaggerated. The tilt between the orbital plane of the moon around Earth and the ecliptic plane, namely the Earth's sun orbital plane, it has been exaggerated. But now it is like this. So imagine that the sun is somewhere in this direction. Okay. So, or let's make it, because this is the brighter part. So I'll make the sun in the rightwards direction. So sun is somewhere here. So the moon is going around in this plane. So obviously when the moon comes here, the some portion of the moon gets complete rays, sun rays, and here it will be, you can see here it will be the full moon. Now as it goes around, there'll be a time when the moon is in a position where it has come to this point. When it is at this point, the, the outer part of the moon gets the full radiation from the sun. The other part, which we are seeing, will be completely dark. However, note that the Earth is going around sun, while this plane will keep its orientation as it is. So this line will be oriented as it is. And you might ask, why is this plane, why would the plane remain the same according to the reference frame from the ecliptic? It's related to the angular momentum conservation. Anyway, let me not go too much into the physics. So therefore, as Earth is going around the sun, this line is always pointing in this direction. So there'll be a time when the line comes, Earth along with this line, and sun comes in the same line. Then if the moon was in this position, you will get lunar eclipse, while if the moon was in the other position, you will get solar eclipse. So therefore, it is this line of intersection between the moon Earth orbital plane and the sun Earth orbital plane that tells us that lunar and solar eclipse will happen only when moon is either at this point or at this point. Otherwise, you will have the usual phases of moon. Okay. Now, I will slowly go into the physics aspect, but before that, I must tell you that moon played a very, very important role in the discovery of the laws of gravitational force. Okay. So the normal story we are told is that Newton, he realized that this force of gravity when an apple fell on his head. Well, that is not the complete story. After all, we know that we can't jump and escape out of the earth, and most people knew that something is keeping us to the earth. But the genius of Newton is this. He realized that apple falling or I falling from a tree sometime, or any objects falling towards the earth, there is the same effect of moon going around sun. So Newton's genius was to realize that moons going around the sun is actually moon going around the earth is essentially moon falling due to Earth's gravity. This realization was what made Newton a genius, that an earth falling to the ground and moons going around earth being moon falling in Earth's gravity, this connection was made by Newton. Okay. So, and therefore, how did he immediately realize that there has to be inverse square law? What he realized was this, that from Galileo's time, measurement of the acceleration due to gravity was near the surface of the earth was already known, and we all know it is 9.8 meter per second square. Newton, probably in his time, he did not realize the moon is actually going in an elliptical orbit, but is very close to a circular orbit anyway. And Newton realized that moon going around in an orbit means there's a centripetal acceleration, because by then, after all, he had already given his laws of motion, and any object going in a not a straight trajectory but curved trajectory is accelerating. And if anything goes in a circular orbit with speed v and radius r for the circle, then we know there's centripetal acceleration v square by r. By then, people had already estimated the distance of moon from the center of the earth. Okay, and we already know that moon takes about 28, a little excess, 28 point something days to cover a full 360-degree. From that, you can immediately, the radius, the distance is known, the time period is known. From that, you can immediately find out the speed. Why? Because 2 pi r will be the length of the circumference, and time period is about 28 point something days. So 2 pi r divided by this will give the speed, and Newton could immediately estimate the centripetal acceleration v square by r, and it turned to be very tiny, 0.00272 meter per second square. While the acceleration for falling bodies near the surface of the earth is much, much larger. Then Newton took the ratio and tried to see, can he estimate some pattern about radius of the earth and the distance of the moon from the earth. And lo and behold, he got the inverse square law of gravity, and he established, therefore, that the force, gravitational attractive force between moon and the earth, is the magnitude of it is given by the Newton's universal gravitational constant capital G times mass of the earth, mass of the moon, divided by the earth moon distance square. Okay. So therefore, as you can see, that the leap of imagination that happened in Newton's mind, that apple falls, even the moon falls, that led to the famous inverse square law of gravity, and which we have been constantly using. Any space voyage or any explanation for astrophysical objects, they largely deal with this universal gravitational law. Right. Now remember, before I leave this slide, according to the gravitational law, the force is not uniform, is 1 over r square. So therefore, points which are far away, that means this point compared to this point being far from earth than this point of the moon sees less force in this direction, while this point of the moon sees a greater force. So therefore, due to Earth's gravity, the moon gets stretched in this direction and compressed in this direction. Okay. Of course, these effects are very tiny, but nevertheless, because of the fact that the gravitational force is distance dependent, different points on the surface of the moon sees a different gravitational force due to Earth. So therefore, moon will not be, its own gravity will try to make moon completely spherical, but because of this differential gravity due to Earth, moon will be wee bit compressed in this direction and stretched in this direction. This differential gravitational thing is called the tidal effect of the gravitational force. There's a reason why it is called tidal effect. I said how Earth's gravity will slightly deform moon. Moon does the same thing to Earth. These regions of the Earth will be getting attracted to the moon greater amount than this part, while the center of the Earth will be getting attracted more compared to this point, but less compared to this point. So therefore, what this will make is that surface of the earth should also get a stretching. And the fact of the matter is, we all see the effect of the stretching. After all, tides, we know that anyone who has lived in a coastal place knows that there are times when the sea is sort of, it comes much closer to the shore compared to the times when the sea recedes from the shore. This is because, by the way, although in this picture only moon is shown, not only moon, even sun does the same thing. So a combination of sun's tidal gravity and moon's tidal gravity leads to the tides. And in particular, moon and sun are the same direction during the eclipses, both lunar and solar eclipse. Tides are maximum. So the oceans being loosely held to earth, the deformation, tidal deformation due to the gravity being distance dependent, shows up on the ocean. All right. Now you all know that the moon's orbital period around earth is about 28 point some fraction days. But you can ask, what is the spin period of the moon? Right? So it turns out that the spin period of the moon is also 28 point the same. And this is the reason why we only see the same face of the moon all through. Okay. So for example, look at this arrow and it's pointing towards earth. As the moon goes, moon is also rotating in the same direction. If moon is going in this direction, it is also spinning in the same anti-clockwise direction. Okay. So when moon comes here, just like about 90 degrees is executed in the orbital direction from here to here, 90 degree, but it is also rotating with the same period. So this arrow will also change direction by 90 degrees, will be pointing in the same direction. Same when it comes to this position, same comes to the point, this position. So in other words, what we see is, because of this orbital period and the spin period being identical for the moon, we will only see the same face of the moon all through. Okay. Unless we go to space, unless we actually go beyond moon or on moon to the other side, we will not know how the other side of the moon looks like. And there are some theories from certain observation. They say that moon is somewhat, the matter concentration is not uniform. Okay. So this is one of the big questions that astronomers and astrophysicists are working on, that why is it that the matter density of the moon is not uniform? Right. But you might ask, what is the reason why the spin period and the orbital period of the moon are identical? Again, it is to do with the tidal deformation of moon. Because of the tidal deformation, remember, it will be stretched in this direction and compressed in this direction, but the moon is also moving around earth. So when it goes this, the stretching and compression will be directed in this. So therefore the stretching and compression direction changes. Because of this, there is a tidal torquing, and the tidal torquing is what slows down, no matter what its earlier spin period was, but because of the tidal torquing, it has got slowed down, because one way to reduce the angular momentum is by torquing, and the torque has reduced the angular momentum of the moon to such an extent now it is spin synchronized. By the way, same thing is happening to Earth also due to the moon. In fact, the spin energy is going into the orbital energy because of the tidal torquing, and the distance between Earth and Moon is increasing. As astrophysicists and astronomers have pointed out, billion of years ago, Moon was much closer than Earth. But because of this tidal torquing, energy is being transferred from the spin rotational energy to the orbital rotational energy, and the distance between them is going up. Right. So the tidal torquing also does the other effect. For example, we know we have all played with lattus or the tops, and when you spin a lattu and throw it on the ground, initially the top is rotating with the spin axis close to the vertical. But as it slows down, it starts precessing. Why does it precess? The precession is because now, when it is in this position, with respect to the ground, the Earth's gravity causes a torque because the gravitational force is not aligned with the center of gravity and the point of contact. So there's a torque, and we know that there's a law which says rate of change of angular momentum is equal to torque. Because of this torque, the angular momentum no longer is conserved, it changes. And the direction of the angular momentum is this, so it changes in this manner. And as I said earlier, that Earth's spin axis is not vertical with respect to the ecliptic plane, but it makes an angle of about 23.5 degrees. So question is, why does it make an angle? The angle is again because of the tidal force, the Earth gets deformed as the so-called high tide in this and low tide in this direction. And because of the deformation, there is a torque, and the torque makes it precess. So the axis is not pointing all through in the same direction. For example, today we know the axis points toward the Dhruvatara or the pole star. And that's the reason why, as the night progresses, all other stars apparently move in this direction, but Dhruvatara remains static. And that is the reason why the Dhruva story is there, that Dhruva was so fixed in his meditation that he did not even move. And that story is given to say that Dhruvatara is static. But 25,700 years ago, the pole star was not the point in the line of the axis of rotation, but it is the Vega star. Okay, so this has very important implication of dating our Rig Veda actually. If there's a question, I will tell you later, but let me, because the time is, it's almost 1 hour gone by. So let me go just to complete it. The tilt plays a very, very important role, as you know, in our change of weather. So, for example, when Earth is in this position and Sun is here, again, don't bother about the sizes. Sun is much, much bigger than Earth. These are just to illustrate the physics behind the changing weather. So, when Earth is in this position, the northern hemisphere is tilted towards the sun compared to the southern hemisphere. So the sun rays are direct. It's nothing that to do with distance, but because the tilt is toward the sun, the amount of radiation per unit solid angle on the surface of the Earth is much greater on the northern hemisphere than the southern hemisphere, because of which northern hemisphere undergoes summer weather while the southern hemisphere undergoes winter. So if it is summer in India now, or May and June summer month, during that time Australia, New Zealand had their winter. While when it comes to this point, then the since the northern hemisphere is pointing away from sun, northern hemisphere will have winter, while southern hemisphere will see summer. There are 2 points when, of course, the spring and the autumn equinox, when there'll be a time when the the length of the day and the length of the night will be exactly equal. Let me not go to other aspects because today is the super moon day. I'll stick only to the subject of moon, but I would really like if you ask questions, because it's more important to ask questions. Otherwise, it would be only a one directional monologue. So I'll actually stop here and I will actually invite questions. Thank you. Hello, am I audible?
Hello.
Yeah, yeah, I can hear you now. So it is more important that students ask questions. So I
Yes,
have,
sir. Let me
yeah,
check it with my team. They they can pin the comments over here in this chat. So now I think you can see. So you're not audible actually, I think.
no, I'm not able to see the questions. What do I have to do to,
So you cannot see the questions on the screen?
no, I can see uh, a greeting from Teja Bagari.
No, no, sir, no, sir, not that. Just hold on. Okay, sir. Then I think there is some technical difficulty. I will just ask you the questions orally, and you can then answer the
Sure,
questions.
sure,
Okay.
sure.
So the first question is why the moon is drifting away from the Earth.
Very good question. So let me go back to the slide. Yeah, as I said, that the tidal force of moon on Earth causes this bulging of oceans, and there's also a tilt. Because of the tilt, there's a torque acting on Earth, just like there's a torque acting on Moon due to Earth's tidal forces. And just like Earth's tidal force has locked Moon's spin, Moon's tidal force is also trying to do the same with Earth. So Earth's day is also increasing somewhat. But you might ask, if this is what is happening, that the rotational rate is decreasing both for Earth and Moon over the time, then what about the total energy? After all, there is the orbital kinetic energy, but there's also rotational energy associated with spin. If the rotational spin energy is decreasing due to tidal force, the energy cannot disappear. Where does the energy go? A, a somewhat lengthy calculation would show the energy is actually going to the orbital energy of the moon and Earth. So, in other words, the kinetic energy, orbital kinetic energy of the moon as well as the Earth is increasing while rotational energy is decreasing. But if the energy goes up, then the distance between moon and Earth will increase. Why is it so? Because of the fact that when your gravitational equilibrium is there, then when the kinetic energy goes up, the potential energy energy must become also, because some kind of a virial relation that twice kinetic energy is equal to minus of the gravitational potential energy. So if kinetic energy is going up, the potential energy also should go up because of this result 2t is equal to minus v. But potential energy, how can it go up? It can go up only if it the distance between the earth and the moon increases. So that is the reason why the distance between moon and earth is increasing with time. I hope I have made it clear as to why the distance between moon and earth is increasing.
Okay, sir. Sir, the next question is right
Yeah,
here.
so
The
I can
next question
now
is
see the question on the screen. Why the
yes, sir.
moon always shows Earth the same face? This I had already explained using this figure. So let's go to the figure. Yeah. So the reason is this, that moon goes around the Earth in a time duration of 28 point, let's say 28 point x days. Okay. The moon is also rotating about its own axis. And you can ask, what is the period of rotation about its own axis? That number is also 28.x days. So the two numbers, namely the rotation period, orbital rotation period, and the spin rotation period, they are identical. If that is the case, then we can only see the same face of the moon as moon embarks on its voyage around Earth. Why is it so? Let's suppose we start from this position, that this point of the moon, this arrow, you mark an arrow on the moon. Okay, so someone marks an arrow on the moon, and we are seeing the moon in this direction. We are seeing the arrow is pointing towards us. Then moon, as it is moving in the orbit, the moon is also spinning around. So from here to here, when the moon goes, how much how much angle has it covered? From here to here, the angle is 90 degree. Okay, so this line and this line, the angle is 90 degree. But because this arrow must also change by 90 degree from when it goes from this point to this point. Why? Because the spin period is same as the orbital period. So this arrow should also rotate by 90 degree in this direction. So therefore, when the moon comes here, the arrow is still pointing towards us. Now the logic can be extended from here to here. Total angle covered is 180 degree. From here to here, 180 degree has covered. So this arrow from here to here also must rotate by 180 degree. So therefore, again, you see that arrow is pointing towards Earth. And so is it in this case. So in other words, at all times, the arrow will be pointing towards us. And therefore, this proves the point that we only see the same face of the moon all through. I hope I've answered your question. Is it possible that in future moon is hand? Well, as I said, that the time scale is very long. So by the time moon completely escapes Earth, it will be 10 raised to power 12 years, much more than the age of the universe today. So therefore, before that, much disastrous thing will happen. For example, as you know, sun will become sun will become a red giant after about 10 raised to the power 9 years. And a red giant being sun will be expanding and will expand to such a big size that Earth and maybe even Mars will come within the sun's photosphere. So this will happen in another billion years. So Earth, Moon, Sun, Earth, Moon, Mars, they will all get evaporated. They'll be within the sun then. So that will be much more uh, catastrophic than what you're imagining. I hope I have answered your question. Could there ever have been life on the moon? Well, it's very difficult to answer it now, even if at some point, again, there are many theories as to how moon formed, whether the moon was pulled away from Earth or moon was captured by Earth, it was another body. But I think the present day observations give more credence to the theory that moon was pulled out of the Earth, and more evidence is for that scenario. So even if when that happened, first of all, that happened more than uh, 9 billion years ago. So the question is, did was there life on Earth during that time? We don't know. So let's assume that when moon got pulled away from Earth due to some other heavy object coming by and tidally ripping apart a portion of the Earth, suppose there was life on Earth during that time, and therefore some amount of life would go into the moon. But moon, when it went to such a great distance, then with no water or minimum water, no atmosphere, no carbon dioxide or oxygen, and constant UV rays from sun bombarding high energy cosmic ray particles from sun uh, all the time irradiating moon. Even if to begin with there was life, the life would be exterminated because of this uh, very disastrous conditions that are prevailing on moon today. Yeah, so good question. So remember, both Jupiter and Saturn, they are huge planets. And you might ask, how did the solar system form? How did the planets form? So the whole idea of solar system formation is there was this huge gas cloud which had some amount of rotation, and when it started collapsing, conservation of angular momentum will say that the rotation rate will go faster and faster. And when the rotation rate goes faster and faster, the centrifugal force makes the high rotation part of the contracting cloud into a disk. When the centrifugal force, which is radially outwards, when it is very large, the portion of the cloud will become disk, and the central portion, which didn't have much rotation, it will collapse, and that's how sun formed. The disk slowly, the grainy part of the disk, gaseous part, there were uh, different compounds like graphite and silicon dioxide, the grains so called, they were solidified and become bigger and bigger, and they gave rise to planets. But the planets themselves, remember, they are all condensing out of gas. There'll be some amount of rotating uh, gaseous thing about each of these grains. And if you have a bigger planet, there'll be a bigger amount of gas rotating about the bigger planet, and they will soon condense. The grain part will soon condense into satellites. and Jupiter and Saturn being much larger, the gaseous disk around Jupiter and Saturn would have been much more massive, and therefore, when they condensed, they gave rise to a numerous satellites around Jupiter and Saturn. So it's the whole issue is about the way different planets formed. And Jupiter and Saturn, they are big. They were much more bigger and gigantic gaseous planets with disk of gas around them. And just like central gaseous thing collapsed, shrunk to give rise to today's Jupiter and today's Saturn, the outward disk, that the grain part, they coalesced and became the moons. While Saturn, some amount of gaseous part is still remaining in the form of ring around the Saturn. And the reason why these theories make sense is that you will find that all the moons of Jupiter are roughly in the same orbital plane. Well, helium 3, which is an isotope of helium 4, it is much more uh, uh, unstable than, I mean, it's an isotope, so therefore it is not as stable as helium 4. So it is, I mean, when and where the future lunar mining takes place, one should be able to find helium 3 and collect it. But again, the question is, when will there be a lunar colony? Is there any other question?
Is there a
Sorry,
question?
I, Lunar Maria, is it? What is that?
Yes, I think so. Lunar Maria,
Well,
something.
there are these huge craters on Moon, and craters uh, form when meteorites and meteors, when meteors strike the surface, they, because of their huge kinetic energy, they cause the craters. And I had asked the question, why is it that Moon has many more craters than Earth? Let me give you the answer. One is that I mean, there are two factors really. One is that moons, unlike Earth, Moon doesn't have an atmosphere. So what happens when a meteor enters Earth's atmosphere is the friction makes the meteor uh, develop high temperature, and most of the meteors, they get burnt out as uh, ulka in the atmosphere. Rarely, of course, you will find a meteorite on the surface, and there are craters like Lunar crater in Maharashtra. There are craters on Earth too, but Moon has greater number of craters primarily because of two reasons. There is no burning out of the meteors. The other thing is because Moon is geologically almost dead, means there is no atmosphere, wind sort of trying to smoothen out the crater. So whatever crater formed in the past, they have got frozen. While in on Earth, even if you have a crater, there are lot of geological activities like wind will carry sand and dust and fill up the crater. There'll be tectonic plate movement cause earthquakes. So geological activity on Earth tries to sort of uh, erase lot of these craters, while Moon is geologically dead. So whatever craters since time were created, they are all large number of craters together would give rise to a huge uh, depression on Moon. So probably this would answer your question.
Sir, I don't think that there are any more questions in the chat, but I would give them a last chance to put their questions in the chat box. If anybody is having any other questions, please put the questions in the YouTube chat box. Any other question, thanks.
Yeah. Uh, so yeah. So for that Moon is, first of all, as I said, it is geologically dead. There is no atmosphere. So the portion that is directly getting the sun rays will be much hotter than, as I showed you, the spin axis of the Moon is not as much tilted as the Earth. So therefore, there are regions on the Moon which are perpetually not seeing any sunlight. So they will be extremely cold. It is like our Arctic or Antarctic, because they are the polar regions. So therefore, the temperature there is much, much small compared to the temperature in the equatorial region. And in the case of Earth, because of the tilt being 23, about 23.5 degrees, the Arctic and Antarctic, they do have daytime. So Moon, in the case of Moon, the tilt is not much. So there are regions on Moon, the polar regions, that are always under shadow, and therefore they will have sub-zero temperature. While again, the axis not being so high, the equatorial region of Moon will always see the maximum amount of solar radiation and will continue to be very hot. And because there is no atmosphere, the there is no air that will try to cool away the surface temperature. And that's the reason why you have such a high gradient of temperature. And in fact, some time back, I envisaged, if this is the case, we can have a thermocouple, one point at high temperature and the other point at low temperature. A gigantic thermocouple can be used to generate electricity. Why not every new moon day is solar eclipse? Yeah, this is something I'd explained, but let me go to the. Yeah, so as I said, that the orbital plane of Moon Earth, the red part, is inclined with respect to the Earth Sun orbit, the blue line. And therefore, the Moon is going around in this plane, while Earth around the Sun is going in this purple plane. So the purple plane is that of the Earth Sun orbital plane, while the yellow plane is that of the Moon going around the Earth plane. So suppose Sun is somewhere here. Of course, this figure is highly exaggerated. Although this angle here it is 5 degree, but we know that this angle is too huge. But for the purpose of explanation, the exaggeration has been made. So
Sir,
suppose this,
sorry to interrupt you. Are you sharing the
yeah,
screen?
sorry, yeah,
Sir,
I'm
are you?
sharing the screen.
Sir, but the screen is not visible. Yeah,
It's
now it
not
is
visible.
visible.
Now
Yes, sir.
visible. Okay, okay.
Now
Yeah, good, good. So now look at this uh, figure. So if Sun is in this direction and Earth is here, so therefore Moon is going around in this trajectory. So when sun is here, earth is here, as the moon goes around, there'll be time when moon is somewhere here. Earth is in between moon and sun, but moon is here. So moon will see the entire sun radiation, so it will be full moon. While when in this position, if the moon was here, the this part of the moon will get the sun radiation, but the part that is facing the earth will be dark. So it will be the new moon. But as I said, that earth is also going around the sun. So this line, moon going around, this nodal line, the line of intersection between the moon earth plane and the earth sun plane, there'll be a time when the line comes exactly here. And then, so now imagine the sun is somewhere in this direction. So the line is here and sun has come in this direction. If sun is in this direction and the moon comes here as it is rotating about earth, when the moon is here and sun is in this direction, now earth has blocked the radiation from sun, so it will be lunar eclipse. But in this direction, the moon was here. Now moon has come between the earth and sun. So moon has blocked the radiation from the sun. And it so happens the angular diameter of moon and the angular diameter of sun are identical. Not the real size, but angular size. And therefore, moon can block the entire sun and you have the solar eclipse. I hope I have answered your question.
Sir, I don't think that there are any other questions in the chat, but
Right.
please let us wait for 1 or 2 minutes. If anybody is having any other queries, then they can put it
Right.
in the chat box.
Right.
Yes, sir, we don't see any other questions coming. So it was
Okay.
on. I would like to conclude the session.
All right.
So I'd like
Sure.
to say that yes, sir, this was a great session, and I think that everyone who was watching on YouTube, they really enjoyed the stream, and this was it was a great time having you with us, and would like to experience this a few more times
Thank
with
you
you.
for your words. It was my pleasure.
Thank you,
So
sir.
take care. Give my best wishes to Shomajit
Yes, sir.
and
Yes, sir. Yes.
take care, everyone. I really enjoyed the questions. All the best to everyone.
Thank you, sir. Thank you. Okay, so here is a uh, little information for everyone, to our audience actually. That regarding this Moon Day, as you know, we have planned for many events, such as I think there is a quiz, there is a uh, there is a live stream where the view of the moon will be shown using our telescope, and a few more events are there. So please stay tuned with us, and don't forget to check out our YouTube channel and our Facebook, Instagram, website as well, and the Discord server. Don't forget to join the Discord server. And thank you, everyone. I'm signing up for today.